Hello everybody, so we're going to be learning today about oxidation of food and antioxidants, and it links in quite nicely to what we've been doing recently, which was the oxidation of alcohols, the oxidation of aldehydes, and learning all about the carbonyl groups in aldehydes and ketones and their chemical reactions. So let's have our prior knowledge questions. I've done two completely at random, which aren't really related to this lesson, and then one at the end, which is more related and will hopefully help you out. So you're going to need a calculator for the first one. It's one of the mole calculation ones. Let's get started. So it should take you a few minutes, this one, so just pause and then we'll go through the answer together. Okay, so what I've done is I have written out the equation here and I've underlined the chemical that we're trying to find the mass of. So it says in the question, calculate the mass of magnesium chloride in grams present in the magnesium chloride solution. So there's my equation. It's all balanced. It's all nice. It's basically just copied exactly as it is above. I've then used the information in the question to help me calculate the mass of the silver chloride. So it says in the question I have 1.393 grams of silver chloride. So I have therefore calculated that. I've calculated the number of moles of that, and I've used the GFM, which is given in the question as well. So I haven't used the data book for this. The ratio is 1 mole of magnesium chloride to 2 moles of silver chloride. So I've halved the number of moles to give me the number of moles of magnesium chloride. And then I've used that number of moles, 0.0048. I've times it by the GFM, and that has then given me a mass of 0.46 grams of magnesium chloride. Okay, so I've got the marking instructions up on the next slide, and you can have a look at those, have a read of these in your own time, please. Okay, let's continue. So this is right back to the beginning of Unit 1. It's asking you to put down some information about the ionization energy. Okay, here we go. So again, you can just pause this and you can read through this on your own time. Just a reminder that the left-hand column is the correct answers and the right-hand column is the additional guidance, okay? Next question. So we need to remember what an isomer is. Hopefully we can, but if you can't, it is the chemical which has the same molecular formula but different structural formula. So you have there 3-methyl-butanol. Can you rearrange those atoms to form a ketone? And a ketone, if you remember, has the carbonyl group somewhere in the middle of the chemical, flanked by a carbon on either side. And one of the possible answers, or three of the possible answers you could have had, are the following there. Okay, here we go. So it's not going to be a particularly long one, this, but let's get started. So our success criteria are: number 1, can you describe and name the process when edible oils undergo oxidation? Number 2, can you state how antioxidants work to prevent the oxidation of food? And number 3, can you identify a substance as an antioxidant from a redox equation? And then we've got some past paper questions to help you out as well. Okay. Okay, so the oxidation of food. So I'm not going to read this out, but if you can have a read of that, please. So part of the reason of why foods go off, and it's quite a complicated process, but one of the reasons is due to this oxidation here. And we've seen this in apples. If you've ever cut an apple and left it on the side for a little while, that browning is caused by oxidation. Another example of this is if you have oil and it's been left in the back of your cupboard for a long, long time, and if maybe the lid's been left off or something, if the oxygen can get in there, then it can go rancid. And the oil itself is then hydrolyzed, and we've got a little equation to show you that. So our oil undergoes oxidation, and then we form glycerol, and we also form fatty acids. And these fatty acids are not particularly nice. They're quite pungent smelling. They make the oil taste not very nice as well. So it's quite clear when this has happened to your edible oils, your olive oil, your sunflower oil, and so on and so on. Now, one way you can get around your food going off is by adding something called, or using something called, an antioxidant. And you may have heard of antioxidants in terms of dietary supplements. And I've got a little video later on that I really recommend, I would like you to watch, which looks into the science behind using antioxidants as dietary supplements. But we'll get to that later. But for now, this is a definition of an antioxidant. So here we go. So antioxidants are reducing agents and they prevent the oxidation of molecules in food. The way they do that is because they themselves are oxidized ahead of the chemical in the food. So in the example of this here, we have an apple here, it's gone brown on one side and it's not gone so brown on the other side. And there's a video again later on which shows an experiment as to how you can actually achieve this. But here's the science behind it. So we have this damaging free radical, which has been produced potentially by a reaction with oxygen. The antioxidant comes along and it donates one of its electrons. So it then becomes itself a stable free radical. By giving one of its electrons to the damaging free radical, that free radical is now stabilized. It is not interested in going around and reacting with other chemicals. And so this now would prevent the food from going off. So if you can please watch these two videos, the top one I'd like to watch, and then we're going to go through the results. So in the video that we watched there, the apple had, some of them were left on their own and some of them had lemon juice added to them. And the ones that had lemon juice added to them, they didn't undergo browning. The reason why they didn't is because what lemon juice contains. And lemon juice contains vitamin C, which is a very common antioxidant. The chemistry behind what's actually happening with that vitamin C is as follows, whereby ascorbic acid, which is the scientific name for vitamin C, undergoes oxidation and it becomes dehydroascorbic acid. It loses 2 hydrogen ions and it loses 2 electrons as well. How do we know, though, that this is oxidation? Well, we know it's oxidation because, one, we have loss of electrons, but also if you counted the oxygens and hydrogens, and you may remember from last time that if our oxygen to hydrogen ratio increases, then we can class this reaction as an oxidation reaction. And these electrons here, well, they're going to go and stabilize the free radicals that are causing the browning. And that is us. So let's go through some past paper questions. Have a go at this one, please. So the first one here, during the reaction, the oil molecules become rancid. So B is the correct answer here. So in this question here, this is one of the learning intentions. Can you identify the antioxidant in a chemical reaction? So for the first one, here's the answer. Okay, moving on. Okay, next set of questions. So what sort of reaction has taken place here? Well, you could have a look at the oxygen to hydrogen ratio and see what's happened there, and hopefully you would have found that it hasn't increased. And so therefore it must be something else. So what's actually happening? Well, we're adding oxygens and hydrogens, we're adding H2O specifically. So what sort of reaction is this? Well, it's an addition reaction, or specifically it's a hydration. And the reason why the chemical would not undergo oxidation, in other words, no reaction would happen, is because it is a tertiary alcohol. And that's us. So we've covered describe and name the process when edible oils undergo oxidation, that's they become rancid. State how antioxidants work to prevent oxidation of food. They themselves are oxidized, they're classed as reducing agents and they donate some electrons. And then identify a substance as an antioxidant from a redox equation. So you're looking for the chemical that is being oxidized. Okay, thank you for watching, and if you can get the Google form to me as quickly as possible, that would be appreciated. Bye for now.